Hello everyone. Welcome to the video lecture series of data structures. What today's topic is singly linked list insertion, but in ordered linked list. Hi, this is your instructor Janice Shah. So let's begin with the algorithm for insertion in ordered linked list. So students, what we have seen in our previous sessions. In our previous session, we talk about the insertion in the linked list as well as at the first and the last. In the both of the algorithms, we learn how can we use the availability stack. How can we take a node from the availability stack? Okay, how we can assign the new to avail and then do avail arrow link of avail. What is avail? Avail is nothing. It's a top pointer which is pointing to the topmost element of the availability stack. New is what? So new is our new pointer which is going to point our new node. Okay, whatever we are going to insert. So usually we need to take our node from the availability stack. Fine. So these all steps are common in this ordered linked list. Okay. So let me start with the algorithm. So students, first we need to understand about that what we need to write over there. See, this is the insertion in order linked list. That means again the insertion in the linked list. That means it's a function. So it's like function insord. Insord, it also means like insertion in order linked list. So always remember the name of the algorithm must be meaningful. Now next thing, what we need to understand over there also. So this is the first and x over there. X, what x represents? X represents the value which are going to be inserted in a new node, and the first shows the value of the first pointer. Fine. That means that shows exactly the starting node of the linked list. Okay. So let's begin with the algorithm. So students, just let me know what are the basic steps to perform over here in the algorithm. First, we need to check the underflow condition. Okay, but before that, we need to take availability stack over here. See, this is our availability stack. Okay, and we need to check the underflow of it. If the avail is equal to null, that means your availability stack is underflow. I have already explained the process of the availability stack in our previous lectures. If you didn't see it, just check out the YouTube channel. Go and check the videos of the availability stack as well as the insertion of the first and the last of the linked list. Fine. So here the first condition is underflow. How to check the underflow condition? Whether my ability stack is underflow or not. So that means you cannot insert a new node. Okay. So here it is. If avail is equal to null, then you can write like ability stack is underflow. You just need to write the return first. Students, return first, because in the algorithm of the insertion, what we are going to do is we are going to return the value of the first node of the list. Fine. So here the pointer value of the first node of the list, that means the value pointer value address of our first node is going to be returned. So what will be our next step? If avail is not equal to null, then you can take a node from the availability stack and insert in your linked list. Okay. So for this particular purpose, we are going to do the two different steps, which are very much common in our all three algorithms of insertion. Step number one is to assign a new pointer to avail, that is new arrow avail. We already know how I can write like new arrow avail, because who points to whom? If A points to B, you need to write an algorithm like new arrow avail. Okay, such like this. Next step is avail arrow link of avail. We need to move avail pointer from here to the down, because we need to take this particular topmost node. So step number two is this is my avail, which is going to point the link of avail, and this becomes my new link of avail. After that your new node is free to take. So the new node will be removed from the availability stack and it will go like this. So this is my new node, students. What is the next step? See, each and every node contains two different fields. One is info, second one is a link. One is info, second one is a link. So here I just need to initialize the fields of the new node. So here I initialize the field of the new node, that is info of new is equal to x. So here x is over there, info of new is equal to x. Now, sir, just assign the link. Okay, students, I'm going to just assign the link of the new node. So the link of the new node is null first where? I don't know. Because see, this is ordered linked list. You do not know where to insert this node. do not know where to insert this node. So wait, you cannot write the or you cannot initialize the link of the new node over here. Okay, so what we are going to do is we are going to assign the link of the new later according to the situation and the condition of the linked list, whatever we are thinking about it. Okay, so just skip this step, move towards the next one. So the next step is first copy the information of the new node. I'm just repeating this step, nothing else. Now the first condition is, just imagine a situation, students, that your linked list does not exist. Now again tell me when the linked list does not exist. When the first pointer is pointing to null, because if a linked list does not exist, that means first is pointing to no one, that means null. So you can check if your first is equal to null. If your first is equal to null, then whatever the new node you are going to take, that, see, this is the situation. If your first equal to null, then whatever the new node you are going to take from the availability stack, that will become your first node, and also it's your last node. Fine. So what happens? This is my first node. Whatever the new node I'll take from the availability stack, that will become the first node of this ordered linked list. Yes or no? Yes. So this will become my first. This will become my last. That means the new node is my first node. New node is my last node. If and the link of the last node is pointing to null. That means link of the last node is pointing to null. So here, whenever I'm going to take this, then I need to initialize in such situation when the linked list does not exist. The new node becomes my first and the last. That's when the link of the new node is pointing to null. Okay, and see, your node is already inserted. So what you need to do, you just need to write like return new. Why? I already told you we used to return the address of the first node. That means the pointer value of the first node, that is return new, because new is pointing right now. New is your first node, new is your last node. That's why the link of new is equal to null, and we write return new. So this is your first condition when linked list does not exist. Now let me give you the next condition. The next condition is, does a new node precede all the nodes of the list? What does it mean? Does a new node precede all the nodes of the list? That means it wants to say that whatever the value you are going to insert as a new node, is it lesser than all the nodes of the list? Then what happens? It must be inserted at the first position. If this is your linked list, this is a linked list like 10, 20, 30, 40. Fine. And if you are going to insert 5 over there, then 5 is lesser than all the values. 10, 20, 30, 40. 5 is lesser than all the values. So 5 must be inserted over here. Okay. Then 10, 20, 30, 40. So 5 must be inserted at first position of the linked list. And you already aware about how can you insert that. Fine. But for this, you need to check something. Okay. So what to do? See, you need, this is the ordered linked list. Okay. So what happens? We just going to check the value with only the first node. Okay. So see, if x is equal to 5, if x is equal to 5, I am going to check the value of x with the value of first node. Now, let me know what we call the value. We call the value as info. If you remember, in this algorithm, we call the value as info and the pointer as link. That means data as info and the pointer as link. So here the data we have x is equal to 5. The info is 5, which we want to insert in the new node. Fine, that's okay. But what we have in the first node? In the first node we have 10. That means 5 is lesser than 10. That means it precedes all the nodes of the linked list. So what we need to compare info of new if info of new is less than info of first. Okay. So the condition is if info of new is less than or equal to info of first, then your new node must be inserted at the first position. That means the link of new, see, this is my new node. Okay, students, this is my first node. This contains 5, this contains 10. If this is the lesser than the first, that's why it will be inserted over here. So the link of the new node will pointing to the first node. So this is how you can assign the link of the new node to the first node. So the step when the info of the new node is less than or equal to info of first, students, you need to write down link of new arrow first. Now again, in this situation, students, the new node becomes my first node, so I have to write return new. Fine. So your two conditions are completed. Now, what next? See, this is the third and the major condition that we need to understand. So students, in this condition, what we are going to taking is, we just need to initialize. See, right now we don't know that where to insert, because we need to insert this particular node in any between of any two nodes. Fine. So I am going to initialize a temporary pointer which is known as save. We already know this type of situation in our, when we want to traverse in the linked list in to find out the last node. So you already aware about the save pointer, that this is nothing but it's a temporary pointer which we are going to initialize at the first. Okay, so right now the save pointer is pointing at first. Okay, fine, it is there. Now what do you want to insert? Here the value of the x is already given. The value of the x is 60, students. I want to insert 60. Now let me check out my linked list first. Okay, so I will get the idea where I want to insert it, and then I'll think about the connection of the links. Okay, so here, students, I have 10, 40, 50, 65. The last one is the 80. So 10, 40, 50, 65, and last one is the 80. So I am going to insert this 60 value in between of 50 and 65. Sure it is. I want to insert this value in between of 50 and 65. Okay. So what to do for that? For this particular situation, students, I need to move my save pointer. I need to move my save pointer. Now, the situation is that where to stop this save pointer? Where to stop this save pointer? Okay, now imagine a situation. If you stop your save pointer at 65, if you stop your save pointer at 65, then what is the name of 50? Do you have any name? What to do in linked list? If you want to do any operation in the linked list, students, always remember that you need to assign a pointers. You must have the pointers to the particular nodes. Okay, so you can identify them. Here, this is my 65 value. Okay, and this is my 65 value, this is my 50 value. Okay, so this is 50, this is 65. What I need to do, I just want to identify the name of both of them. Okay, so if my save pointer is stopped at 65, I will not able to find out the name of the 50. But if my save pointer will stop at this 50, then I can easily say the link of save is 65. If this save is 50, then link of save is 65. Fine. I'm going to do the same thing over here. I'm going to stop my save pointer at 50. Okay. So how to do that? See, just need to write the condition, like basic condition is repeat while link of save is not equal to null. See, to search in searching of this value, you should not move out of the linked list. That's why you have to write like this: link of save is not equal to null. And another condition is info of link of save. See, this is not an info of save. Info of link of save. Why? We'll see in the example. Okay. So info of link of save is less than or equal to info of new. Okay. Fine. So let's start. If these both conditions are satisfied, then what happens? The save will move towards the next one. Okay. Now let me show you what this info of link of save and what is info of new. Now see. Right now my save pointer is at first. Right now my save pointer is at first. So the condition is link of save is not equal to null is true. Okay. Now second condition. Second condition. Okay. In X we have 60. Okay. We have to compare 60 with what? 10. Wait. We are comparing 60 with 10. No. We are comparing 60 with 40. Why? It is info of link of save. If save is at 10, if save is pointing at 10, then the link of save becomes 40. Link of save becomes 40. Students, if the link of save, okay, link of save becomes 40. If my save is 10, save is pointing at 10, then the link of save becomes 40. So what happens? The save will move further because 40 is less than or equal to 60, the condition true. Now students, the next one, okay, what happens over here? Just see it carefully. My save pointer is pointing at 40. Okay, so the link of save becomes 50. Link of save becomes 50. Now, info of link of save, that means 50. 50 is less than or equal to 60. Condition becomes true. 50 is less than or equal to 60. Condition becomes true. So we need to move save to link of save again. So now save pointer is pointing at 50. Now, see here. See, here my save pointer is pointing at 50. So link of save becomes 65. Link of save becomes 65. Now, info of link of save is less than or equal to info of new. That means 65 is less than or equal to 60. The condition is false. Condition is false. So at this point, your save pointer will stop the traversing. Got it? So what we have right now, we reach our destination. We have 50. Okay, we have save at 50. Okay, we have 65 with us. Okay, now what we need to do, we just need to put our 60 in between both of them and connect the link. So this is how you can perform, you will reach to your destination. Now the next step. Now this is very important step. We just need to set the links of the new node over here. How we will do that? See, I just put my 60 over there. I just put my 60 over there in between of 50 and 60. Now, remember one thing. Remember one thing. For the insertion or any operation in the singly linked list or W linked list, anything, whatever your new node is there, you just need to assign the link of your new node first. You have to assign your link of the new node first. Then think about the rest one. Okay. So here what happens? See, this is my 65, this is my 50, this is my 65, this is my 50, in between of them we have 60. Okay, so what I need to do is 50, 65 and 60. What I need to do is I just need to connect the link of 60 to 65. Link of 60 to 65. Now let me know what is the name of 60. What is the pointer which is pointing to 60? That is new. Okay, so we have the name of the 60, that is new. Now, which pointer is pointing to 65? Link of 50. Link of 50, that means link of save. So here we also have the name of the pointer which is pointing to 65. Sir, that is link of save. So we have link of save, we have new, and what are we waiting for? Just connect the link of new to link of save. Link of new to link of save. See, the link of new will connect to the link of save. Okay, so this is a next step. Link of new will connect to the link of save, and then what to do? Save, link of save. Link of save will connect to new because the link of 60 must be connected to new. So this is how you can perform both operations. So now the 60 is already inserted in between of 50 and 65 in just two simple steps. In the first step, what we did, we just connect the link of new to link of save. That means link of 60 to 65, and then connect the link of save. That means 50, link of 50 to 60. That means new. Second step is link of save arrow new. Students, always remember, do not interchange these both steps. Otherwise, your pointer will reflect to the another one. Okay. So the last step is just try to return the value of your first node. Here in this situation when your new node is not inserted the first time or at the first place, so what we are going to do is we are going to return the value of the first only. So last step is return first. Fine. So that's it, students. Today we learn about it how we can insert the value in the order linked list. Okay, a node in an order linked list. If you have any doubt in this session, then please feel free to ask me. Till that, thank you so much.